Welcome for the lecture 6 series of social media analytics, future engineering for social media data. So the previous section we have discussed about the data pre-processing and data cleaning. This series we are going to discuss about the future engineering for social media data. What is future engineering? Future engineering is a process of transforming the raw data into a meaningful inputs for machine learning models. The future engineering process, it will be the input for our machine learning models and deep learning models. This all the machine learning and deep learning models will use the data what we given for the future engineering. Future engineering is the future what I want to predict something or how the flow it will go. So everything is based on the past data. The social media analytics raw data like text, likes, shares, images must be converted into a numerical or categorical features. So we have to the future engineering when I want to apply, we have to come for some standard normalized method of converting our data to the method. Why future engineering is important? It improves model accuracy and efficiency. It reduces noise and redundancy. When I go for a future engineering process, the model accuracy also and efficiency also will be improved drastically. It reduces the noise and redundancy. When I am doing this process, cleaning itself, we are doing this, reducing the noise and redundancy will be removed. It helps the model captures the user behavior and content patterns. So with this, we can capture the behavior and also the content patterns. In social media platform, converting a bits into a words vector. The words vector, which word will come as some more words the particular period. Like that. Extracting the engagement metrics from post. From the post, we are going to understand what are the metrics we extracted from that engagement. It representing the user interaction numerically. So user interaction, how many times the interaction is happened with a numerical count. Text-based feature engineering. What is the text-based feature engineering? Text-based feature engineering, the data is core component of a social media analytics. Whatever the social media analytics we are doing, it is more similar to a data analytics. But data analytics, we can do the data analytics directly with the algorithm what we have. But social media analytics, we have to come to some standard structure for the whatever the word they use from the social media platform. Then we can do all the data meaning, data processing techniques. The common text features are BOW, bag of words. How many words are there repeated how many times like that. TF-IDF, term frequency, inverse document frequency. N-grams, it's a bigrams and trigrams. We will see this more detail about this. These are the common text features are available. Advanced text features are word embedding. In the word embedding, we can use word to VC or glow or contextual embedding, but or RO but sentiment, polarity, and subjective scores. Polarity, whether it is a positive statement or negative statement or neutral statement, this everything. This is advanced textual features. This is the first is a common textual. It's a group of words, frequency of the words, what is the n-grams for that words. These are the mathematical computation for the words present in the social media data. So pre-processing steps. Under the pre-processing, they use a tokenization, stop code removal, stemming and lamination. This three we discussed in our previous data cleaning process. What is bag of words? Represents a text by the count of each word, ignoring the grammar and the word order. So for example, bag of words is, I will just say, for example, particular word is coming, data. So data is repeated how many times? And word is repeated how many times? Like that. But stop word is grammar words that we are not counting. Then term frequency. Term frequency, invert document frequency. Weight words by how important they are in a document relevant to all the documents. So TF is a term frequency, how often the word is appear in a document. IDF, Inverse document frequency gives a lower weight to the common words across the all documents. Frequency is nothing but how much time this is occurring. Bag of words, group of words, the similar mechanism. Word embedding, it represents word as a dense vector in a continuous space, capturing the semantic meaning for that word. That will be done with the help of word to VEC, glow, fast text, word embedding. These are the various techniques are available to do the text feature extractions. Advanced text. First one we seen about a word embedding. Word embedding is a dense vector representation of words. It captures the semantic similarity. The words with a similar meanings are close in a vector space. For example, some word it has another way I can represent that word that will come as a closer similarity. So similarity for this one word, this word has a more similarity index like that. It's a static embedding. Each word has a single vector regardless of the context. Examples word to be glove, fast text, this everything we can take as an example. Static word. These words are fixed, which is comes to this, then the embedding will be takes place. Limitation, it cannot handle the polysim. Same word with a different meaning in different context. For example, if you take some word, in some context, this will be different meaning. In the another context, that same word will have a different meaning. So that type of things and all we cannot handle with this method. The next one is a contextual embedding. What is a contextual embedding? It represents the word depend on the context in they appear. So get clear relation the context. First one with the example what we have seen that has a similarity or something. The same word has some different meaning when you are using a different place. But here it represents a word depending on the context with the they appear. It's dynamic embedding. Same words get different vectors in different sentence. Example, bank in river bank versus financial bank. That's the example. The previous case that both will have comes as the same similarity, but when you use the context embedding method, bank the common word is a bank, but river bank and financial bank both are different. It's a powerful for downstream tasks like question answering and sentimental analysis. The example BERT, RO BERT and GPT style embedding this they can use in the textual features. The third one is a sentiment, polarity, and subjective scores. Polarity means if a text is positive, negative, or neutral. Example, I love this book. This is a positive statement. Subjective. It measures if a text is subjective, opinion or objective, fact. Objective or fact. Subjective or subjective. It is raining, it is an objective. So it's a fact happening. I feel happy. That is based on it is subjective. Objective is nothing but what is happen as a fact. Subjective is my opinion or the person opinion. It can be computed using libraries like TextBlob or WADR or neural models. They can use for the advanced text feature as similar sentiment, polarity, and subjective scores. What is pre-processing steps? Tokenization. Breaking the text into a smaller piece called tokens. Tokens are usually words but can also be characters or subwords. What is a tokenization? Tokenization, we are take a word and we are going to keep that every word as a separate tokens. But models need to work with the manageable units. Computers cannot understand the raw sentence as a human do. As a human, we can read it continuously, then we can get a meaning for the statement. But as a system, they cannot do that type of process. So if you take an example, I love NLP. So they convert everything as a then exclamatory symbol also comes. So they separate every word as a separate tokens. Then they will use this word tokenization function and spacey and transform the tokenization. So stop word removal. Removing the common words that do not carry much meaning in the analysis like is and this and all called as a stop word. So it reduces the noise and speeds up the processing. It helps the focus on words that matter. I love NLP. So here stop word is I. So I will be removed. So love NLP. So tokens, COR, corps that stop words are spacey. They can use this for stop word removal. Stemming and lamination. What is stemming? Both aims to reduce the word into a root format. But differentially, stemming cut the words down their base form using the rules can be cut. For example, words running, runs, ran, stem to run, run, and ran. So this is the step down words. This is, or else they can say a stemming. Come to a root format. Notice that ran may be not converted properly. But also we can say a run. So for this, the parameter what we use NLTK, that porter dot stemmer. Stemmer function we are using a snowball stemmer. This toolkit we can use to stemming the words. Then lamination. Convert the words into a direct base format. So stemming and lamination is a combination process. In the stemming, I cannot get three words are there running, runs, ran, but the two we get a root word run. But ran it is comes as ran only. But when you use a lamination technique using vocabulary and the more accurate stemming method, all will comes as a run. So they will use the word net lamination. This will be used for lamination. Engagement and interaction features. Engagement reflects the user interaction and content impact. The common engagement features are number of likes, comments, and shares. How I can say they are the engaged user? They get some likes, some comments, and shares. It's fit the count and replay count. Its derived features, its engagement rate equal to likes, comments, and so it is not the engagement rate how you are calculating. It is not only based on just likes, comments, and shares, and virality score. How viral these contents are available. Then comment to like ratio. The interaction network features that mentions and replies. What is the mention they used? What are the replies for the things? Follower and following relationship, influence and centrality metrics. These are the things we can understand the engagement interaction features. So engagement, how I am computing the particular video is posted, how many likes comes, how many shares. So all are combinedly then we can give a engagement scores, how many followers are there, likes, comments, share by followers. I have more followers, but my likes are very less. But if I have less followers, I have more likes. Then we can have the engagement rate and virality score, how viral and popular these contents are there. Time-based pattern removal using a behavioral time. Post time, hour, day, week, day and weekend like that. Posting frequency, how often the videos are posted. Time gaps between the post. The behavioral features, the average response time. So what is the average response time for the each and every process? Then active hours of user. That also has the behavioral feature. Then content consistency over the time, that how consistently they are pasting the content. It is not like that I paste the content, give the content on particular day and I can just leave like. What are the application? With this we can, it is used for the process of trend detection, fake account identification. If someone do the activity, rarely that will be maybe the process of they may as a fake accounts, user engagement prediction. This everything will be done with the help of this temporal and behavioral features. Multimedia feature engineering. Social media heavily relies on images, videos, and audios. Image features color histograms. Object detection is face, text, or logos. Deep CNN model they will use a ResNet or VGC. Video features, the frame level features are used for the video feature detection. Motion and the duration metrics. Audio features, pitch, tone, speech, emotion. So for this is a specifically the analysis will be done in the with respect to the social media content for images, videos, and audios. They open tools they will use as OpenCV, CNNS, pre-trained deep models they can use for the multimedia feature engineering. What are the challenges and best practice? The challenges is high dimensionality. Whenever you are using a social media data, it should be the high dimensionality data will be there, and it consists of more noise and unstructured data will be there. Sarcasm and slang in the text will be there. Multilingual context. The best practice is combine a multiple features types, use a domain knowledge, perform the feature selection, regular validity feature relevance be there. When you come for a quiz, what is a pre-processing necessary in the text analysis to increase the data volume, to clean and transform a raw text into an analyzable form, to make the text more complex, to reduce data speed? The next question is what is tokenization in the text pre-processing? It removing a stop word from text, converting a text into numerical values, splitting a text into a small units like words or sentence, correcting spelling mistakes. Third one is what is the main difference between the stemming and lamination? Both give the same output always. Stemming uses a grammar rule, lamination does not. Stemming may produce non-dictionary words, lamination produces meaningful words. Lamination is fast but less accurate. What does the TF-IDF stands for? Total frequency, information density, term frequency, inverse document frequency. So this is the answer for this. Why is a pre-processing necessary in a text analytics? To clean and transform a raw text into a analyzable form. What is tokenization in the text pre-processing? Splitting a text to smaller units is called, like words or sentence, that is called tokenization. Each and every word has a one token. What is the main difference between the stemming and lamination? Stemming may perform non-dictionary words, but lamination perform the meaningful words. TF, IDF, term frequency, inverse document frequency. So that's all about this session. The rest we will continue in the next session. Thank you all.